Coming up next, we come to the hardest, but also the most important useful measure of dispersion called standard of deviation. In notation, we can write it as SD as a short form, or we can use the Greek letter symbol sigma to represent it. So both of them you can use it in your exam to present standard deviation. Before we take a look on the formula, which you see is a very big one with square root sign and square sign, etc. And then so we need to have some one more new notation first. This one will be called arithmetic mean. You can see I will call it x bar, and so you can refer it like the mean we are talking about. And then in order to look at the measure of dispersion of the data, and then so one of the idea will be using or comparing each data with the mean. For example, if you have 5 data, 1, 2, 3, 4, 5 data, 13, 15, 19, 25, and 28. By calculator, you can simply check that the mean is 20. And then in order to find the SD, it would be like you want to check the difference. For example, 13 minus 20, you have 15 minus 20, you have 19 minus 20, 25 minus 20, and also 28 minus 20. But the problem of it will be you don't know when the result is negative, when the result is positive, because some data should be less than the mean, some data should be greater than the mean. In these circumstances, we want to find a way to get rid of the problem of positive negative. So that's why we add a square to each of the difference, so that no matter the data is greater than or less than 20, we have positive outcomes. Afterward, we want to check the mean, the average of these sum of squares. So that's why we divide it by 5, because we are talking about 5 data. And finally, we want to kind of like remove the effect of square. So that's why we take the square root. And then in this example, can you understand the meaning of this formula about sigma here? So if you have a lot of data, for example, we call it x1, we call it x2, we call it x3, x4, x5, etc. And if we have n data, we call it the last one to be xn. In this case, we are checking the difference of sum of squares. And then we want to find the average of it, so that's why we divide it by n. And then finally, we take the square root of this data, and we've got the result. Finally, you can check the SD of the example 13, 15, 19, 25, and 28 as 5.73 in your calculator. Besides using this formula, you can use the calculator inputting 13, 15, 19, 25, 28, and then you can get the mean and also the SD directly from the calculator. There will be another video for to teach you how to use it afterward. Okay, so now we come to take a look in number 17 to see how you find the SD in the question. And then first of all, so you briefly read the question. It's about the records of high jump event. And then so you highlight the unit meter to remind yourselves not to miss it in your answer. And afterward, there are two athletes A and B respectively. So that's why in part A, in order to find the SD, I use the notation called sigma A and then sigma B respectively. Please input 1.86, 1.75, 2.1, and 1.94 in your built-in function in your calculator. And then afterward, you check the SD, which is 0.128 meter for athlete A, And for sigma b, and you should have got 0.115 meter for athlete B. This is quite easy, hopefully, because you need not to do any calculation, but you just input the values into the calculator and obtain the answer. And afterward, there will be a question about follow-up about the values of the SD, talking about like now part B is asking you about more stable performance. And you will see stable, in other words, that means it's less dispersed. In this case, you compare the magnitude of the standard deviations of two athletes, which is 0.115 is less than 0.128. And that's why we call, or we say, athletes B is more stable. It's quite easy, right? And also you obtain 3 marks in example 17. Very good. Next, we go back to another formula on the page, which is called group data. If you still remember, that means I won't give you separate individual data one by one, but they will be categorized into groups. And like example 18, data will be grouped in 51 to 60, 61 to 70, and so forth and so on. And then in this situation, the formula looks to be quite terrible. So that's why we pick example 18 to demonstrate the idea. In each group, for example, 51 to 60, and then there are 32 data given by the question. So that's why you need to find a class mark which represents the range of the data in this class interval. And then do you remember how to find a class mark? Yes, it comes from the mean of the starting number and the end number of the range. That is 51 plus 60 over 2, which gives you 55.5. Similarly, you have 61 plus 70 over 2, which gives you 65.5 for the second group. And then you can see the pattern of the numbers 55.5, 65.5. So that's why you can guess the numbers onward will be 75.5, 85.5, 95.5, and also 105.5 respectively. So that's why we finish the question in this way. In the calculator, there is a way to enter 32 55.5 in your calculator and 72 65.5 into calculator, and so and so. So it will be told you how to use it in another video lesson. But for my convenience to explain the formula on top, so that's why now we try to use the formula directly instead of using the calculator program. So first of all, I have checked the x bar, that means the mean of these totally 150 data, and it should be 67.567. So what do you mean by frequency in the formula? That means in order to find the SD of this question, if you really apply the formula directly, and then you have 55.5 minus x bar square, and then I'm quite lazy not to write the number every time, but use x bar to replace it. And so that's why we have 65.5 minus x bar square, 75.5 minus x bar square, 85.5 minus x bar square, and 95.5 minus bar square, and finally we have 105.5 minus x bar square. But in this case, it can't tell you the effect of the frequency, because in each of the difference, the square of the difference, and it doesn't tell you about the numbers of 55.5, how many times it appears. So as a result, we need to multiply 32 because I have 3255.5 here, and I should have, okay, no space, 72 missing, 33 missing, 10 for 55.5 minus x bar bracket square. I have 2 times 95.5 minus bar square, and also 1 times of it. And then finally, there are totally 150 data, and at last, you need to take square roots of it. It will be quite terrible, right? But generally speaking, how many times the data appears? For example, 32 times. Then you multiply 32 to the bracket square over there. And then at last, the SD should be 9.40, correct to 3 significant figures. So this is the general picture about standard deviation. And then finally, in this page, I would like to go back to another special term which is called variance, which appeared in different DSE papers, like the one I attached in example 29. You can take a look afterward. It is another measure of dispersion to we may use in our life or in our study. And the difference would be we don't have separate sign, or simply it is equal to sigma squared. We will elaborate its variance more in another example. After we have learned all the 3 measures of dispersion, then we come to a very quick highlight of the difference or pros and cons of these 3 measures. First of all, we recall the idea of range, which is talking about the maximum value minus the minimum value. It's pretty easy, right? So that's why I would say the calculation is the simplest, because you just check for the largest and the smallest value. And then, so the disadvantage, of course, it will be, so we only consider 2 data, and then so that's why sometimes there may be a bias. And then also, because maximum and minimum value, it may be quite extreme, and you will see, let's write down the word called extreme data. For example, you have experience, okay, in a certain math exam, one of your classmates are very smart, and she may get like 99, for example. And then, but actually most of you got like around 70 something or 60 something. So that's why the result of her is pretty extreme, we will say in this way. Another extreme will be maybe one of you was sick in the examination, so that's why you only got like 20 something marks. And then if we use 99 minus 20 something marks as talking about the measure of dispersion, it may not be fair enough to talk about the measure of dispersion of your class, because indeed most of you are like 60 something, 70 something, some of you maybe 30 something, 40 something. So that's why range itself is very easy to be affected by extreme data, especially it appears in the maximum minimum. In this situation, so that's why we have another term called Integrator Range, which will be using Q3 and Q1 and check for the difference. And then so it purposely kind of like designed so that it won't be not affected by the extreme value, because the maximum minimum kind of they will fade out in when we are talking about Q3, Q1. And then so, but once again, it cannot show the dispersion of all data, because you are talking about the 2 representatives called Q3, Q1. And then you have also experienced some headaches in finding Q3, Q1. Sometimes it's not quite easy, maybe like in Simon-Leaf diagram. And then one of the most important thing is you have to sort the numbers from the smallest to the largest so that you can find the Q1, Q3 easily. So it is one of the drawbacks. And then finally, the perfect one we will say is the standard deviation, because all the data are taken into consideration, and then it won't be biased by certain data, like maybe in the range. But of course, the drawback will be, so the calculation is not easy, though you have your calculator built-in program for help to do so. And then so it would be a very brief summary about these three measures in your syllabus. And then you can take a look in exam 19 to see whether you can pick the most suitable measure of dispersion you have learned in the chapter.